Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about input-output hardware in operating system. So in this session, we are going to see what are the different applications of input-output interface. So let us see the overview of this presentation. So in this session, we are going to see the different applications of input-output interface. So input-output interface. There is a need of interface whenever a CPU wants to communicate with input-output devices. So there is an interface to communicate with the input-output devices. The interface is used to input address which is generated by the CPU. So it generates some address to access the CPU. The surface is used to communicate to input-output devices, that is to share information between CPU and input-output devices. Interface is used which is called as input-output interface. So, however, whatever you are communicating, so CPU to input-output devices. So, you are communicating some interface. So, you are communicating with CPU and input-output devices. So this is an interface. You are sending and receiving. It is an interface. If in this interface, it is used to interpret some address. So you are having some CPUs having some addresses, and whereas input-output devices also are having some addresses. So these addresses are generated by the CPU. These are generated by the CPU. And they can easily communicate to input-output devices, and they are sharing the information between CPU and input-output devices. So data is shared and data is received. Data is sending, here you are receiving data. This is how the interfacing is occurring between the CPU and input-output devices. What are the various applications of this input-output interfaces? Application of input-output interface is that we can say interface have to access to open any file without any kind of information about that file. So it can open any file by any kind of information. So whenever you are opening the file, that file may be any kind of information. Either it may be an image file or video file or any audio file, any text file. So the file may be any kind of information. That is, even basic information of file is unknown. So whenever you are using that information until and unless you open that file, you cannot imagine that which type of file it is. So it is unknown of that file. It also has feature that can be used to add new devices. So it is having some extra feature to add some new devices to the computer system. Even it does not cause any kind of interrupt to operating system. So when you are adding some new devices to the operating system, it cannot interrupt any kind of arrest to the operating system. Why? Because you can add a number of devices. Why? Because you are having some connection to input the device or output device. So you can connect a number of inputs to the connections. If any interrupt occurs, that can be solved through operating system. It can also use to abstract differences in input-output devices by identifying general kinds of interrupts. So whatever the differences between the input-output devices which are identifying that interrupts, that can be handled through all this operating system. So whatever the interrupts are occurring, that all are handled by this operating system. The access of each of general kind is through standardized set of functions which is called as interface. So there is a standardized set of function known as interface. This is how the interface is done between the CPU and input-output devices. So each type of operating system has its own category for interface of device drivers. So whatever it is having some categories to solve the interface between the CPU and input-output devices. The device which is given may ship multiple drivers, for instance drivers for Windows, Linux, AX, Mac OS devices may is varied by dimension, which is an illustration by the following table. So whatever you are taking, the drivers may be for Windows, Linux, AX and Mac OS. These are all varied through different types of dimensions that are illustrated by the following table. So here we are having the table basis, alteration and example. What kind of data it is? Let us see. Mode of data transfer, it is a character or block or any terminal disk. So when it is mode of data transfer, the alteration is character or block and example is terminal disk. Then what is the method for accessing data? It may be a sequential or random. So one after the other can be checked sequentially, or it can directly say this file. So random, sequential access or random access. Example is modem or CD-ROM. Next, transfer schedule. Either it is synchronous or asynchronous. Example is tape or keyboard. Sharing methods, dedicated or shareable. It may be dedicated or shareable. Example is tape and keyboard. Speed of device. So what is the speed of device? Latency, seek time, transfer rate, delay between operations. So next one is input-output interface. What does the input-output interface can do? It can read only, write or read-write. So both read-write. Examples are CD-ROM, graphics, controller, disk. So these are all the informations gathered for the different types of device drivers. How we are going to perform data transfer, access the data, how we are going to transfer the schedules, sharing methods and speed of each devices, and what are the input-output interfaces. So next one is character stream or block. So these are some applications performed for input-output interface. First one is character stream or block, sequential or random access, synchronous or asynchronous, shareable or dedicated, speed of operation, read-write, read-only, write-only. So let us start with character stream or block. In this character stream or block, both transfer the data in form of bytes. It may be the data may be in the form of bytes. The difference between both of them is character stream transfers bytes in linear way. So linear way means one way. So it can transfer the data by using bytes of memory in linear way, one after the another, whereas block transfers byte in single unit. So one byte, it consists of single unit. The data can be transferred in the block wise. Next, sequential or random access. To transfer the data in fixed order determined by device, we use sequential device, whereas user to instruct device to seek to any of data storage locations, random access device is used. So whatever the data is transferring, that may be under sequential access or it may be a random access. When you are going to send in a sequential manner, you are going to send file one after the other, whereas random means one at a time. So that is what accessing in sequential or random access. Next, synchronous and asynchronous. Data transfers with predictable response time is performed by synchronous devices. So when you are giving some response time, that are performed in the synchronous device in coordination with others aspects of system. So in the coordination of others, they are going to accept from system. An irregular or unpredictable response time not coordinated with other computer events, it exhibits by an asynchronous device. So whatever the data you are exhibiting from the system that are coordinating with asynchronous device, so it's exhibiting some an asynchronous device. Synchronous means performing in a predictable way, whereas asynchronous means it is irregular. Synchronous means regular, asynchronous means irregular. So transferring the data in a predictable manner and unpredictable manner. Next one is shareable and dedicated. Several processes or threads can be used concurrently by shareable device, whereas dedicated device cannot. So, several processes or threads can be concurrently shareable. So, they can be shareable through the all devices, and they can be dedicated, which the device is not connected. Speed of operation. The speed of device has range is set with a few of bytes per second. So speed of this operation may be bytes per second to few gigabytes per second. So per second is bytes of memory. When it is few seconds means gigabytes. Per second means bytes. Few seconds means gigabytes. Read write and read only and write only. Different devices perform different operations. Yes, different devices perform various kinds of operation. Some supports both input and output, but others supports only one data transfer direction. Either it is input or output. So while transforming or performing some operations, that may be under read, write or read only. So this is how the operations are performed in these applications of input-output interface. So in this session we have seen about applications of input-output interfaces. So there are different types of applications that are performed in input-output interface. So if you have any doubts, you can comment in comment box. Thank you.